Let's solve a triangle. In this case, our triangle is not labeled, but we're given that alpha is going to be 30 degrees. I'm going to go ahead and label things as we get going. I've just drawn a very ambiguous triangle here. It's not drawn to scale by any means. It's just a triangle. So I'm going to, after I've drawn this, go ahead and label the sides that I do know. So alpha, I'm putting in that corner. That'll mean A is going to be on the opposite side length. We don't know where beta is. I'll put it down here. We do know B is going to be opposite beta. So we can put 12 on this side. And then finally, gamma and C is going to be opposite that, is going to be 24. All right, so just based on the information that we know at this point, I see that we know one angle. We don't know the opposite side length. I know we can't use law of sines unless we have an opposite pair, like the angle and the side opposite that. We don't know either of the other two angles. So we're kind of limited on where we should go with this. We really want to use the law of cosines in this situation. Because a couple things, we don't know it's a right triangle, no 90-degree angle that we know about. And secondly, we don't have an opposite pair to use the law of sines. So we want to solve for, I would probably solve for A next, in all honesty, because we know the angle opposite that and we know the other two side lengths. So what I'm going to use is this top version of our law of cosines. So the A squared equals B squared plus C squared minus 2BC times cosine of alpha definition. So as we get plugging in there, I'm going to first get A squared. That's the unknown. So I'll leave that on the left-hand side. And that's why I picked this version, is we know B and we know C and we know alpha. We know everything on the right-hand side of this equation. We just don't know A, and that's on the left-hand side. So that's why I went with this version as opposed to the other two. All right, so we've got A squared equals B squared, 12 squared, plus C squared, 24 squared, minus 2 times B times C times cosine of alpha. And alpha in our case was given as 30 degrees. So I'm just kind of filling into this formula. All right, from here, we can do a little bit of simplifying down if we so choose. I'll say A squared is equal to, well, 12 squared is 144. You could go ahead and just get the calculators out, in all honesty here. If you wanted to, I'll leave this as 576 times cosine of 30 for the time being. All right, and maybe the last reducing down you may do before you apply a square root to get A all by itself and get rid of that square is combine 144 plus 576 is going to be 720 minus 576 times cosine of 30 degrees. And we still have the A squared on the left-hand side for the time being. What I want to do next, and to isolate A all by itself and get rid of that square, is apply that square root to both sides. Now, I'm not worried about the positive and negative because A is a side length on a triangle, so it has to be positive. It wouldn't make sense for it to be negative. Get the calculators out, make sure you're in degree mode, square root of all of this. And no, I wouldn't reduce down before I put it in my calculator. I put it all in at once. I got 14.87, whatever those units are. For A. All right, now we still don't know either of these other two angles. So we have a couple options now that we have an opposite pair. We have A and we have angle alpha, which are opposite one another. That's what I mean by an opposite pair. So we can go back to the law of sines if we'd like in this case. If I were to do that, I would probably set it up as sine of 30 degrees over A, which is 14.87. So sine of the angle over the side length opposite. And then it doesn't really matter which one we want to solve for next. We can solve for either beta or gamma. I'm going to choose to solve for beta. So I'm going to go sine of beta over the opposite side length, which is 12. Now, I've got my equation. I would like to isolate the sine of beta next. So to do so, I'm going to multiply both sides by 12. So sine of beta is going to be on the right-hand side as I've written it. And I can put that 12 up in the numerator if I'd like. Everything else comes along. All right. the last thing we need to do to get beta out from inside of the sine function is I would apply a sine inverse or arc sine to both sides. So sine inverse or arc sine, those mean the same thing. Now I'm doing the same thing to both sides of the equation, and that's perfectly okay because these are one-to-one functions, sine inverses anyway. So that'll put beta on the right-hand side all by itself for us. On the left-hand side, I would put this all in my calculator. So second sine to get sine inverse, 12 times sine button, 30 degrees, close some parentheses, divided by 14.87, probably close off my sine inverse parentheses, press enter. And when we do that, I'm going to get 23.80. And I guess that's got to be in degrees. So go ahead and label it there in our triangle, make sure that makes sense for where we're at. Now, you have to be a little bit careful whenever you apply a sine inverse to both sides when you're using the law of sines, in that you may end up with what comes out of the calculator. This could be an angle that's being used as a reference angle for the one we actually want into the second quadrant. Let me quickly show you what I mean by that. Sometimes what would happen is if you use 23.8 in the second quadrant as the reference angle and calculate the angle that wraps around into the second quadrant, if you plug this angle that wraps into the second quadrant into sine as well, you're going to get this exact same ratio coming out, this decimal, I guess you could say in this case. Now, I know that's not going to be the case on this one. And why I know is based on this angle. If I calculated the angle in the second quadrant that uses 23.8 as a reference angle, that calculation would look something like this. It would be 180 degrees minus 23.8 degrees. So we got 180 minus 23.8. I got 156.2. Now, I know 156.2 degrees is not going to work for our beta. And why I know that is this is a very large angle. If I put that large angle in here, it has to be opposite the largest side length. Okay, so 156, very large angle for beta, would have to be across from the largest side length. Well, 12 isn't even the largest side length. That's the smallest. So it makes sense we're going to have the smallest angle here across from the smallest side length. All right, so I can kind of get rid of all of that. We didn't need that side work. I was just trying to explain out why we knew that we didn't need the second quadrant angle on this one. Now, the very last thing that we should do, though, is we still need to find our remaining angle. So gamma. And to find gamma, we know that all the angles in a triangle always add up to 180. So if I start with that and subtract away the 30 that I already know is accounted for and the 23.80 that's accounted for, what's going to be left is going to be our gamma. So in this case, gamma is going to be 126.2 degrees. You can't put it in the triangle. Now we know all three angles, all three side lengths. So we've solved this triangle is what we say. I will go ahead and mention some students get frustrated with this. Is it supposed to be a reference angle in the second quadrant or not? You can avoid that worry. Basically, that I went into the extra sidebar over here about if instead of pulling out the law of sines like I did, when you have the opposite angle and side length, if you went back to the law of cosines, you're never going to run into this problem using law of cosines. So what I would have probably done is trying to find beta. I would have used this version here. The cosine of beta equals the a squared plus c squared minus b squared all over 2ac. Plug in all those side lengths we know on the right-hand side, then apply a cosine inverse to both sides, and you're going to get beta pretty quickly. And it'll come out the right answer the first time, every time. You don't have to worry about this extra thought process. So anyway, hope this helps out as you're solving non-right triangles using the law of cosines. Good luck.